and I will share my screen. Okay, everybody can see my screen, you can hear my voice.
Yes, can, Doctor.
Okay, thank you for the response. Okay, so last week we have stopped until this slide regarding the type of communication system. How can we classify the communication system? We can classify into three categories, what we have learned in the previous slides. Okay, so we can classify the electronic communication systems using based on three conditions, either based on the transmission mode, one way or two way, either this system is analog or digital system, or baseband or broadband transmission. Okay, there are three ways to classify the communication system. Macam mana nak mengkelaskan communication system ini boleh dilihat dari from three aspects. Okay, transmission mode, analog or digital, baseband or broadband transmission. Okay, so we're gonna flash back a few slides previously so that we can have more understanding of what we will learn after this. Okay, so before that maybe I will check the, okay, someone want to enter the class, so I will admit the entry. Okay, okay, so okay, so transmission mode, if you want to classify the communication system in terms of transmission mode, we can classify whether this communication system using one-way or two-way communications. Okay, so one way is what we call as simplex, means that the signal travels in one direction only. So that means you can only receive or transmit only at all time. For example, this mostly used in the TV broadcasting and also in the radio system. Of course, when you watch the television, you only see the television, see and hear the television. You are not transmitting signal to the TV station. So that's why you are receiving the TV signals. Okay, and also similar with the radio. Okay, FM radio, for example, you're listening to FM radio, for example, like Hot FM, Era FM, Surya FM, and whatever. So you are listening, okay, you are receiving the radio signals, and you are not communicating to the other side. So this is what we call as simplex communication. Okay, the other one is a duplex, two-way. That means both parties can communicate to each other. And duplex can be divided into two categories, half duplex and also the full duplex. So half duplex, only one direction, signal can travel in one direction at a particular time. Okay, so that means we are exchanging communication one at a time. So when one people start sending the signal, the other will receive, and while the other person send the signal, we receive the signal. So only one way at a time. So this is, for example, like the walkie-talkie system. If you know about the walkie-talkie, for example, like the police radio, that means when one people use the walkie-talkie, one people speak, the other one will listen, and when that person speak, this person will listen. So only one way at a time. So this is half duplex. Full duplex, signals can travel in both directions simultaneously. For example, like the telephone system. Okay, your telephone system, for example, when you call your friends, both of you and your friends can talk simultaneously at the same time. Okay, so signals are transmitted in both directions continuously at the same time. So this is what we call as the full duplex. Okay, so for your information, this transmission mode has been asked in the previous test and final exam. So I can say that these are one of the favorite questions in test and final exam. Okay, and then what? Then we can also classify the communication system either as analog system or digital system. Okay, as I've mentioned in previous week, that analog system, for example, like this one, analog, we have the transmitter, okay, and we have the receiver, okay. So the transmitter receive analog signal, it will process as analog, and it will transmit as analog. The receiver receive as analog and process it as analog, and then produce output as analog. So all signal processing involved in this system is in the form of analog. Okay, so this is what we call as analog system. Okay, and it is actually possible to transmit analog through the wired system. It is also possible, but most of the time we use the wireless system for the analog transmission using electromagnetic waves. Okay, and then what? Digital system. So digital system can be divided into two categories. The first one is digital transmission, or a true digital system, where digital pulses are transferred between two or more points, and there's no analog carrier in the true digital system. Original source info may be in digital or in analog. If analog, convert to digital pulses prior to transmission and converted back to analog signal. It requires physical medium between the transmitter and the receiver side. So regarding the digital system, for example, like this one, so I redraw again this one. Okay, so the beauty of a digital system is that we can the input can be either analog or it can be in terms of digital pulses. Okay, so the transmitter will process the input as digital code word, digital data, and when it wants to transmit, it has the flexibility either to transmit as an analog or to transmit as digital using electrical pulses. So for the first one here is about a true digital system which transmit using a digital pulses. That means you have the digital data. How you want to transmit this digital data across the medium, and in this case it is said that most of the time it requires physical medium. That means it uses the cable. Okay, and how the transmitter wants to transmit the data inside the medium, it needs to convert the digital data into electrical pulses. Okay, so electrical pulses, that means you are converting the data 101010 into electrical pulses, either in terms of voltage, for example, okay, voltage or current, okay, and pass through the medium. Okay, and then the receiver, okay, will process it as digital, and it can produce either digital output or produce analog output. Okay, this is the good thing of digital system. You can have the flexibility to choose. Okay, and then what? Digital radio. So the word radio here means that the digital data is converted into analog, which is in the form of electromagnetic waves. So what happened here is, again I draw again. Okay, so again we have the flexibility to have the input of analog or digital. Okay, and transmitter process it as digital. Okay, and in digital radio it involves modulation with analog carrier. So the carrier is analog, and what you will produce is is the analog output. Okay, the analog signal which carries digital data. So you see that although you transmit as an analog, but the content is digital data. Okay, and in this case, for example, this is you will produce either ASK, FSK, or PSK signals, and transmitted through the wireless medium. Normally through the wireless medium. Pada kebiasaannya dipancarkan secara wireless. Okay, and then this is the receiver. So the receiver receive the analog signals, process it as digital, and you have the flexibility to choose either to produce analog or to produce digital output. Okay, and this normally transmit through the wireless medium, and it can also be transmitted across the wired medium, also possible. Okay, and then what? Advantage of digital transmission. So why do we need to use a digital transmission compared to analog transmission? Okay, first of all, it's about the technology which provide low cost VLSI technology. Okay, the system is low cost for the processing. You can produce a better quality of signals, and then data integrity. You can transmit at longer distance with high quality. Okay, compared to the analog, there's going to be a problem if we transmit in a long distance due to the attenuations. Okay, due to the attenuations and also due to the interference. Okay, but in digital system, we can transmit the signal in a longer distance because we can have a few set of repeaters between the transmitter and the receiver. Okay, so kita boleh letak beberapa repeater antara transmitter and receiver. So the repeater regenerate again the digital signal so that it can be transmitted in a long distance. Compared to the analog cannot be regenerate. Analog signal cannot be regenerate. Instead, you can only to amplify. Okay, so that's why amplification is different from regenerate the signal. If you can regenerate, you can transmit in a long distance. Okay, regenerate means menghidupkan semula. You make the signal alive again. Okay, you recreate the signal. Okay, and then what? Capacity utilization. So it can support high bandwidth for commercial links, high degree of multiplexing easier with digital techniques. So you see that in digital system, all data is in the form of 101010, different from the analog. Okay, analog signal. Analog signal has infinite shapes. Okay, infinite shapes compared to the digital, where there's only two possibilities. So yeah. Okay. So all signals in digital are in the form of 101010. That means from any kind of signals in digital, we can classify it in terms of digital data 101010. So that means if all signals if all digital signals are the same, either can be categorized as logic 0, logic 1. So we can easy for us to do the combination or multiplex. Okay, kalau semua signal itu mempunyai two possibilities, either logic 1 or logic 0, that means easy for us to multiplex together the signals and send it into the medium or channel. And then security and privacy. Only in digital system we can do the encryption, not in the analog. And then for digital system, we can do the integration with analog and digital combined together. Okay. So this is the thing that I've explained previously, that we can receive, we can have an input analog or digital, and we can produce either analog or digital at the output side. Okay, so this is integration of analog and digital. And then the third one, broadband or baseband or broadband. Baseband is using the base frequency dasar. Okay, and baseband is usually referring to the low frequency transmission. Okay, so baseband, if you see from the theoretical concept, it is a low frequency starting from 0 until a few kilohertz. Okay, for example of base frequency is like our voice. Okay, our voice is a baseband low frequency, which is not suitable for long distance transmission. We need to do the modulation techniques. Okay, and how to transmit in terms of baseband? There's a way to transmit in terms of baseband. So baseband transmission, in this case, okay, so we are not modulate the input with the analog carrier. Okay, it does not involve analog modulations with the carrier. Okay, so it is using a base frequency. So digital signals are used, but it can also be used with analog technologies. Frequency division multiplexing is not possible because the bandwidth is small. Okay, baseband is bidirectional, short distance signal traveling. Entire bandwidth of the cable is consumed by a single signal, for example like the Ethernet. Okay, so in this case, baseband, first of all, it uses a low frequency and it contains a low, it has a low bandwidth, small bandwidth, which is not suitable for transmission. Okay, and another thing is that it does not involve modulation with the analog carrier. Okay, tidak melibatkan proses modulation dengan analog carrier. Broadband. So broadband transmission. So the word broad here is referring to the bandwidth. So the bandwidth is higher, bigger, and we are using a high frequency transmission. What frequency is this? This is radio frequency transmission. Okay, so when we want to use a broadband, that means we are converting a low frequency input into a high frequency output. For example, like my voice, if I want to transmit my voice into a long distance, that means I need to modulate my voice with the analog carrier so that it can be transmitted along the medium. Okay, for example, like I'm using the mobile phone. Okay, my voice is a baseband, and then I speak through the mobile phone. The mobile phone do the modulation process, okay, with the analog carrier. So the carrier is in the cellular frequency or radio frequency, more than 900 megahertz and above, using a 4G frequency band. So after the modulation, that means my voice has been converted into a higher frequency and larger bandwidth, which is suitable for transmission. Okay, so in this case, it involves modulation with carrier, okay, and can be transmitted across the medium. Okay, the medium can be wired or wireless, no problem. Okay, so analog signals are used, okay, because when we modulate with analog carrier, we will transmit in the form of electromagnetic waves. Okay, so electromagnetic waves is in the form of analog. Okay, signal traveling at long distance, frequency division multiplexing is possible. Why? Because we have larger bandwidth. We can combine many signals together and transmit it into the channel or the medium. Okay, signal are sent on multiple frequencies and allow all multiple signals sent simultaneously using broadband transmission. This is multiplexing. For example, like DSL and also cable television networks. So now we start for this week. This week we actually continue again. Because last week we stopped until here. Okay, so that means this is the graphical picture to show the analog input or digital input and also analog output, digital output. Okay, so when you see the word data, this is normally referring to the input to the system. Okay, and signals is a word that normally produced by the system. Okay, so previously, as the picture that I've shown you before, like this, okay, so the input here is normally assigned with the word of data. So when we heard the word data, it is actually referring to the input, and what it produced by the transmitter is actually what we call as a signal. Okay, it just the the words that been used in the notes. Okay, in the lecture notes. Okay, so for example, like analog data pass through the telephone will produce an analog signal that will be transmitted across the wired medium, for example. Okay, so analog data, for example, like your voice, so the telephone system will modulate your voice and then send it through the wired medium. Okay, so you have analog input, analog input, analog output. Here is you have the digital input and you produce analog output. So this is done by the modem. Okay, done by the modem. So modem is to do the modulation and demodulation. Modulation, demodulation, so the name is modem. Okay, and over here you're going to have analog input, digital output. Okay, you can do this using the specific codec. Okay, you have the for example, you want to encode your voice is in terms of analog. You do the encoding process and you produce the digital pulses like this. Okay, digital signal. Another one is that you have the digital input data and you produce digital output. Okay, so this can be done by the digital transceiver. So transceiver is the combination of transmitter and receiver. Okay, so any equipment that can be both at the same time, transmitter and receiver, it is what we call as transceiver. For example, your mobile phone. Your mobile phone is also a part of, your mobile phone is also a transceiver because it can act as transmitter and receiver at the same time. Okay. Encoding techniques. Okay. So from the previous discussion, it is obvious that we can have 4 types of transmission systems. Either we have the digital data, digital signal, analog data, digital signal, digital data, analog signal, or analog data, analog signal. So again, the data is referring to the input, signal is the word referring to the output produced by the system. Okay. Okay, digital data, digital signal. So that means what? So for example, like the transmitter, okay, for example, like the transmitter, so the transmitter receive the digital input and it want to send in terms of digital pulses. Okay, so how to do this? That means the transmitter needs to use the encoding techniques to to encode the digital input and produce the digital pulses. Okay, so in order to convert the digital data into a digital pulses, we can use what we call as the line coding techniques. So line coding, okay, this is the general terms for all of these encoding techniques. So this among them is the non-return to zero NRZ level, NRZ inverted, bipolar AMI, Manchester coding, differential coding, and many others. Okay, so there are many line coding techniques available in the practical system, which converts the input into digital pulses. Okay, and then what? So need to know about timing based signal levels. Okay, factors affecting the interpreting of signals. This is the SNR. Factors that affecting the input signal is the SNR, data rate, and also the bandwidth. So we're going to see about this later, about these issues. So digital data, analog signal. So that means the transmitter receive digital and you want to produce analog. You want to produce analog. So you see that here is the input 0011 01 00010. So this is the input. And in this case, when you want to produce the analog signal and put inside the medium, that means you need to modulate with analog carrier. You do the modulation with the analog carrier. So you modulate the digital data with analog carrier, and you will produce analog signal at the output. Okay, so what it will produce either ASK, amplitude shift keying, phase shift keying, or frequency shift keying or phase shift keying. Remember, when we do the modulation process, modulation will change the characteristic of the carrier in accordance with the amplitude variation of the input message. Okay, so if modulation process change the amplitude of the carrier in accordance with the amplitude of the input message, then it will produce amplitude shift keying, ASK. If the modulation process change the frequency characteristic of the carrier in accordance with the amplitude variation of the input message, then we call it as FSK, frequency shift keying. If the modulation process change the phase of the carrier in accordance with the amplitude variation of the input message, then we will produce phase shift keying, PSK. Okay, so all of this you will learn in chapter 4. Okay, chapter 4. And then what? You have analog data, you want to produce digital signal. So that means the transmitter receive the analog data. You have the analog data, and you want, so the transmitter receive the analog data. You have the analog data, and you want to transmit in the form of digital pulses. Okay, so how to do this? There are many other ways. Either you want to use a line coding, or you want to do the encoding process using a pulse code modulation techniques or delta modulations. Okay, again, line coding is also can also be used. Okay, previously we used a line coding for digital and digital. Okay, so for this case you can also use a pulse code modulation. So both of these and delta modulation, this is types of encoding process. Okay, it does not involve modulation with the analog carrier. Okay, dia tidak melibatkan modulation dengan analog carrier. So the word used here is the encoding. You encode the signal into to become a digital pulses. Okay. Analog data, analog signals. This is, you will learn more details in chapter 3. Okay, so you see that here everything, all signals are in the form of analog, continuous over time. So here is carrier, and then we have the input message. Okay, analog, also analog. Okay, so what happened is that when you do the modulation between these two, again, if modulation change the characteristic of the carrier. So you see that originally carrier is like this, but when you do the modulation, it becomes any three of this. Okay, and if the amplitude of the carrier change in accordance with the input message, then it is what we call as the AM signal, amplitude modulation signal. So you see that originally carrier like this, suddenly the amplitude change, the up and down rhythm, or this ripple is changed. That means the amplitude of the carrier change in accordance with the input message. And both of these below here is frequency modulation signal, FM. This is if the frequency of the carrier change in accordance with the amplitude variation of the input message. And phase modulation, PM, if the phase of the carrier change in accordance with the amplitude variation of the input message. So what is the input message? Input message is this one, the input. The input is what we call as a modulating signal, message signal, or input signal. Okay, you're going to see different terms used in the lecture notes. Okay, so you see that both FM and PM, the waves are almost similar. So what are the difference actually? So you will learn later what are the difference between both of these. Okay, so if you see from these, the two graphs below, okay, you're going to see that the ripples of the waves are close one another and further one another. Okay, this is close one another. This, for example, like this is further away from one another. So this is for this one, this is a high frequency and this is a low frequency. Okay, so you're going to see that the frequency change. Okay, the frequency change, that means the ripples close and further away from one another. So if it is close to one another, this is a high frequency. If it is further away from one another, the ripples is renggang. This is what we call as low frequency. So during this process, frequency change, high frequency, low frequency, high frequency, low frequency, similar with this one. Okay, high frequency, low frequency, high frequency, and so on. So you will learn this in more details in chapter 3. Okay, modulation. Okay, modulation. Why we need to do modulation? Why? As I told you last week, that modulation is a question that have been asked to me during my job interview a long time ago in a Flextronic company. Okay, so at that time, an engineer, one senior engineer at that place asked me, could you please explain to me what you understand about modulation? So there are many things to explain about the modulation. So there are many things involved in the modulation. So you see that when you go to the job interview, They are not asking you very technical questions. Instead, they are asking you about your understanding on the principal concept, okay, on the basic concept. Okay, the question is simple. Explain what you understand about modulation. So from your explanation, they can know how good is your knowledge about a certain topics. Okay. So modulation. First of all, you see that there are many points here actually. Okay. It is extremely difficult to radiate low energy signals from antenna in the form of electromagnetic waves. So the first reason is that we do the modulation so that we can convert the input into a suitable form of signal that is suitable for transmission along the medium for long distance transmission. For example, my voice is not suitable for long distance transmission. So we need to convert this voice into electromagnetic waves, which is suitable for long distance transmission across the wireless medium, for example. Okay, so that's the first reason. So that's suitable for transmission in the medium. The second part is about the antenna dimension. Second. Okay, so second part here is about antenna dimension. So it says that here about C and lambda. So you see that if lambda wavelength is equal to speed of light divided with the frequency. Okay, and if you have a high frequency, that means you can have a lower lambda. If you have a low frequency, then you're going to produce high lambda. Lambda is the important parameter in antenna design. The larger the lambda, the larger would be the antenna size. So if you want to have a smaller antenna size, that means you need to operate at high frequency. For example, like the mobile phone. Okay, mobile phone. So this is using the 3G and 4G frequency band, which is 900 megahertz and above. So you see that the antenna is very small inside the mobile phone. Okay, the antenna is very small inside the mobile phone. And later for the 5G mobile devices, the 5G frequency band is more than 1 giga, so that means you can have you can have a smaller antenna size within the mobile phone. And again, if you go to the 6th generation, which is expected to be deployed after 2030, so that one will use higher frequency. Okay, so the higher the frequency, the smaller would be the size of the electronic equipments. Okay, that's a good thing about that. So that's the second reason. Okay, so and then what? The third reason is about the okay, prone to aperture. Okay, so the third reason is about the multiplexing. Okay, so info signal often occupy the same frequency. Signal from two or more sources are transmitted at the same time. They would interfere to each other. Okay, so this is about the interference. Okay, before that, the third one is for multiplexing. Okay, so multiplexing is the concept is like this. You can have many inputs. Okay, so you can have a carrier over here, and you can have many inputs. You can have many inputs and you can have one carrier, so you can multiplex all the inputs together and carried by the carrier across the wireless medium. And there's also possibility that you can have many inputs and many carrier. Okay, this is called as the high level modulation techniques. Okay, so modulation allows the use of multiplexing to multiplex many inputs and send it to simultaneously across the medium. Okay, Then what? So the fourth reason, this is about the interference. Okay, this is about the interference. So modulation also helps to avoid interference with another signals. Okay, so it avoids interference with other signals because the radio frequency band are regulated by the MCMC, okay, Malaysian Commission and Multimedia Commission in Malaysia, which regulate the frequency band within the Malaysia. So that means you cannot operate at any frequency that you want. Okay, there are unlicensed frequency that you can use at any time, but there are also commercial frequencies that are only designated to, which is that is registered for the specific company or users. Okay, frequency ini sebenarnya there are unlicensed frequency you can use anytime for the citizens, and there's also commercial frequency which cannot be disturbed by anybody. Okay, so modulations helps to prevent interference from another signals in the same frequency band. Okay, interference. What is interference? Interference is a noise that that has the same frequency as your transmitted signal. That is what we call as the interference. Remember, this is about the transmission impairment that you have learned in the earlier slides. Okay, about the interference. So modulation helps to prevent the interference in the channels. Multiplexing. Multiplexing again, combine. The word multiplex means combining many input together and send it simultaneously into the shared medium. And then at the receiver side, it will do the demultiplexing to get the original number of outputs. So you have the n inputs multiplex together, use the shared links, and then at the receiver side will be demultiplex. So this is done in order to reduce the cost and also to achieve a higher utilization of the transmission line. Okay, so you can support many users together using a single line. Okay, multiplexing is very important in the communication system because of the limitation in the channel itself. Okay, FDM is also a part of modulation, a part of multiplexing method. Okay, frequency division multiplexing, which is used in the first generation of telephone system. Okay, this is 1G. Okay, 1G system. Now we are moving to 5G. Okay, so multiple signal shares common bandwidth of single communication channel. Useful bandwidth of medium axis require bandwidth of channel. Each signal occupies a separate portion of the bandwidth. For FDM is for the wired communication system. If it is in the wireless communication, it is called as FDMA, frequency division multiple access. This is the first generation of mobile communication. Okay, FDM for the wired transmission. So how does the FDM looks like? It is based on this picture. Okay, so you see that you have bandwidth. You have the bandwidth. So the frequency is y-axis over here, and the x-axis here is the time. Okay, so that means this is the bandwidth. Okay, so the bandwidth is separated. Okay, the bandwidth is separated into a few frequencies band. Each frequency band is assigned to a specific user or radio station, for example. Okay, for example, I assign radio station Surya FM for frequency band 3, Hot FM frequency band 2, and another radio station frequency band 1. So that means you allocate sub-frequencies based on the given bigger bandwidth. You allocate a portion of the frequency into a specific users. Ni macam kita potong bandwidth itu kepada beberapa bahagian. Okay, so that means if you see from here, if we allocate a frequency sub-frequency into specific user, that means that user can use the bandwidth, the entire bandwidth. The user can only use a portion of the bandwidth, but in any time. Okay, the user can only use a portion of the bandwidth. The user can use a portion of the bandwidth at any time. Okay, so that means user number 3, this user can use this portion of bandwidth at all time, pada bila-bila masa. Okay, this user can use the frequency band, this frequency band, at all time. Similar with this one. Okay, so that means even though user number 1 does not transmit anything, for example, so that means this bandwidth will be underutilized. Okay, if the user does not use the bandwidth at a specific time, that means the bandwidth is underutilized. Okay, kalau orang ini tidak menghantar sebarang signal, maka frequency band ini akan menjadi idle. Okay, it will be underutilized, tidak digunakan sepenuhnya. Okay, so this is about FDM. You assign specific frequency to each user. But the bad side is that it will be underutilized if the user does not use it. Because we already assigned the frequency, so it's up to that user whether to use or not. Okay, and you see that each frequency band is allocated with a guard band. Guard band is the empty space to separate between frequency band and another frequency band, to separate each adjacent channels. Okay, channel 1, channel 2, 3, 4, 5, 6, 7, and so on. Okay, so you see that from this FDM, that means each user can only use a portion of the bandwidth at all time. Okay, now you will see the next part, time division. Okay, time division multiplexing. Time division, that means you divide the time according to time slot. Okay, and each time slot is given to any users that want to send the signal at that particular time. For example, I want to send signal now, so the system needs to allocate me a time slot so that I can transmit my signal. Okay, and then the time slot will be given to another users, for example. Okay, so that means instead of giving the frequency, you are giving a time slot for each user, a limited time, but you can use the entire bandwidth. Okay, if you see from here, okay, so each user can use the entire bandwidth, but only for a short period of time. Okay, for example, user 1, user 2, user 3. User 1 can use the whole bandwidth, but only a small portion of time. Similar with user 2, user 3, and so on. So the good thing about this is that each user has the opportunity to use the whole bandwidth for transmission. So what is the good thing of using the whole bandwidth? Remember, bandwidth is proportional to the data rate. Okay, the higher the bandwidth, the higher would be the speed of transmission. This is similar with your, for example, like your Unify. For example, if you remember your Unify, Unify 100, Unify 300, Unify 500, 800, and so on. So that one is referring to the speed. Okay, that is the speed of transmission. But actually, when you go to higher speed, you need larger bandwidth. Okay, when you go to the higher speed, you need a larger bandwidth. Okay, so this is TDM. This is for the second generation of telephone system. In the mobile communication, we call it as TDMA, time division multiple access, which is for the wireless communication. Okay, so the good thing about this, it will improve the speed of transmission. Okay, TDMA improve the speed of transmission. Okay, and then what? This is for second G. What about 3G? 3G is based on the CDMA. That means we have another axis over here, what we call as codes. Okay, so each user, it can support many users which sign with different codes. Each frequency here, each time slot here has a different kind of codes. So the third axis is another one is codes. So this is what we call based on the code division multiple access, CDMA. So CDMA improve the previous generation by allowing larger number of users sharing the same medium. Okay, not only that, it also improved the speed. Okay, not only the speed but also involve the utilization. That means it can support larger number of users. Okay, that's the 3G. Okay, 4G also based on the CDMA, but it uses a WCDMA, wideband CDMA, wideband CDMA. Okay, 4G LTE. And then what? 5G. 5G will use a different kind of waveform. It is also based on the WCDMA base, but it will support higher transmission rate and support multiple users within the same frequency band. So when you go to the higher generations, 5G, 6G, and so on, there are a few things. The first one is improve speed. The other one is improve the utilization. That means it can support many users within the specific bandwidth. Okay, and then what? 6G. 6G of course later the speed will increase, of course. And what else? What else is about the introduction? Sorry, not the introduction. The implementation, the integration of artificial intelligence within the communication system. So when we go towards 6G, that means the system will have some sort of knowledge to do the processing. It has the intelligence to improve the performance of the system by itself. Okay, bila kita bergerak ke arah 6G, maka akan ada integration dengan artificial intelligence. So artificial intelligence is the next technology for the 6G and beyond. Okay, so that one is about the communication system. Okay, gain. Okay, so I believe starting from here, you will feel excited. Okay, because starting from here is about calculation. Previously is about theoretical concept. Now is about calculation process. So maybe you will feel excited, not feeling tired anymore. Okay, so maybe you can start open your calculator. We can do some calculation after this. Okay, so maybe before I continue, can I get your response? Are you still there? Students, can you respond?
Yes, doctor.
Okay, thank you for the response. Okay, gain is the ratio of output to the input. That means it is output over output divide with input. Okay, so that means gain is the word about improve or becomes bigger. That means the output is bigger than the input. Okay, so if the output is bigger than the input, that means there's a gain from the input is lower. The component gives some gain to increase the value. So this is what we call as gain. Okay, gain means the output is bigger than the input. Okay, how do we calculate gain? Is A equal to output over input, V out over V in. So the word, the subscript V here is referring to the voltage. Okay, so V out over V in, and it will produce value larger than 1, more than 1. Okay, if the value more than 1, this is what we call as gain. Okay, so in some this is A is used in the Wayne Thomas's book. If you read in other literature books, sometimes they use the symbol of G for gain. So no problem, you can use G for gain, or you want to use A to describe the gain, no problem. Okay, tak ada masalah nak gunakan A ataupun G. Okay, so if you see from here, from this example, so we have a gain in your syllabus, normally referring to the component of amplifier, which amplify the input. Okay, amplify the input. So in your syllabus, gain is much related to the amplifier system. Amplifier amplify the input. Okay, that means the output larger than the input. Okay, so A, the gain, is equal to V out over V in, which will produce a value larger than 1. Okay, and then picture on the right here is the cascaded system. So, okay, cascaded system, we're going to have more than one amplifiers, cascaded. So the word cascaded here means that it is combined in a series like this. Okay, so normally in the exam we like to ask question regarding the cascaded system, more than one amplifiers. Okay, so for example here we have amplifier 1, amplifier 2, amplifier 3. Okay, each amplifier has a gain 5, 3 and 4. Okay, and if you want to find the output, you see that so from this equation you see that V out is equal to A multiplied with V in. If you multiply the input with the gain, you will produce the output. For example here, A1 multiplied with the input, so 5 multiplied with 1, you're going to get 5 millivolt. Okay, and then A2 multiplied with 5 millivolt, so you will get 15 millivolt. And then for A3 multiplied with 15 millivolt, so you will produce 60 millivolt at the output. Okay, and then what? Actually, we can calculate from the beginning. We can calculate. We don't need to calculate one by one. Actually, we can straight away do the calculation to find the output. In order to do that, you need to find the total gains, or A total. A total is defined as A1 multiplied with A2 multiplied with A3. So if you have A4, A5, A6, you just need to multiply all together. Darabkan semuanya sekali. Okay, and you're going to find that the total gain is 60. Okay, so 60, if you see from here, okay, I can find the V out equal to A total multiplied with V in. Okay, 60 multiplied with 1 milli, so I'm gonna get 60 millivolt at the output. Okay, this is for the voltage gain. And then what? Most amplifiers also a power amplifier, so that means you can use also in the form of power. What? Okay, so this is AP equal to P out over P in. Okay, you can also use in term of power. Boleh juga dalam sebutan power. Remember, gain is a unitless parameter. Okay, gain is a unitless parameter. Gain adalah parameter tanpa unit because it is the ratio of voltage or power. Okay, example. Okay, so if you have question, please ask me. Okay, I will explain to you more details. Okay, kalau tak faham boleh tanya. Okay, example 1.1. What is the gain of an amplifier that produces an output of 750 millivolt for 30 microvolt of input? So my suggestion, if you get this kind of question, I suggest you to draw on your own. Draw a picture for yourself, no problem. Okay, when you do the solution, just do a simple drawing so that easy for you to find the answer. Okay, so in this question it is about the amplifier. Okay, about the amplifier. So the amplifier has the input V in and output V out. Okay, so the input is, so the output is given 750 millivolt, and then the input is 30. Okay, and the question asks how much is the gain. Okay, so you see that I only use A, so you don't need to worry about AB, AP or whatever A. There is a referring to the gain, no problem. Okay, so A is equal to V out over V in, which is 750 millivolt divided with 30 microvolt. Okay, so please try to use the calculator. 750 milli divide with 30 micro, so you get 25,000. Okay, can you get the 25,000? You need to get try to get the answer. So you need to cross check my answer. Sometimes my answer is wrong because I wrongly put in the wrong values. So you need to cross check my answer as well. Okay, kamu perlu bantu saya untuk check jawapan yang saya tulis. Otherwise the answer will be wrong for the whole semester. Okay. Okay, so example 1.2. So example 1.1 is very easy. Okay, example 1.2. The power output of an amplifier is 6 watt. The power gain is 80. What is the input power? So that means, okay, that means we have the P out is given as 6 watt. Okay, and then the gain is given as 80. And then what? The question asks how much is P in. Okay, so P in is equal to P out. Okay, P out divide with the gain. Okay, so that means 6 divide with 80. 6 watt divide with 80, so you're gonna get 6 divide 80, so you get 0.075. Okay, 0.075, or this is 75 milliwatt. Okay, remember to put the unit. This is power, so it needs to have unit power. Okay, so this is, if you see from here, I always ask the students, for example like this one, for example 0.075 watt. Okay, this is watt, this is watt. What is the difference between this value and this one? no unit. Okay, so you see that there's a very big difference between these two. This is a power which has the unit of watt. This is a value without a unit, unitless. So that means if you are asking to find the power, you need to do the correct units. Otherwise, your answer will be wrong. Okay. Okay, pastikan unit ditulis dengan betul. Okay. And then what? Example 1.3, cascade amplifier. So this one has 3 amplifiers. Okay, 3 amplifiers cascaded. Okay, so you see that it has a gain 5, 2 and 17. So A1 is 5, A2 is 2, A3 is equal to 17, and the input power is 40 milliwatt. P input is equal to 40, and the question asks how much is the P out. How much? Okay, so in order to find the P out, what you can do is first you need to find the A total. Okay, you need to find the A total. So A total is equal to A1 multiplied with A2 multiplied with A3. So this is equal to 5 times 2 times 17. Okay, so this is 170. Okay, 170. And then what? P out is equal to A total multiplied with the P input. So this is 170 multiplied with 40 milliwatt. How much? Okay, so 170 multiplied with 40 milli, so you will get 6.8. 6.8 of what? 6.8 watt. Okay, and to all of you, okay, to all of you, I would suggest you to highlight your final answer. Okay, highlight your final answer. It's up to you. Sometimes the student likes to underline the final answer like this. Sometimes the student like to do hashtag like this. Okay, or you want to circle, it's up to you. Okay, I need to know your final answer so that easy for me to give you marks. Okay, why? Because in the final exam later, your final answer might be below, or maybe on the left side, maybe on the right side, maybe above. Okay, so it is somewhere in the answer sheets. Okay, so I need to know your final answer, because the final answer has the marks. Okay, so make sure you highlight the final answer. So ini kalau if you have question, please ask question. Okay, if you don't understand about this, I will explain to you. Otherwise, I will move to the next slide. Okay, kalau ada soalan boleh tanya.
Betul.
Ya. Yeah.
Kalau unit gain tu ada unit ke?
Gain no unit.
Okay.
Later you're gonna see that gain can be described as decibel. Okay. For this one, gain has no unit. It's a unitless. Okay. So that's why the gain is 5, 2 and 17. Okay. But in the exam later, we will give you in terms of decibel. Decibel you will learn later in the next slides. Okay, for this example, the gain is a unitless parameter. Okay. And then what? Okay, kalau ada soalan boleh tanya lagi ya. So if you have more question you can ask. Otherwise, I move to the next topic, attenuation. Attenuation refers to degradation of signal energy, or in Malay we call it as perlemahan signal, attenuates. Okay, it is mainly due to the in the communication system, it is mainly because of the first distance and also the obstacles within the transmitter and the receiver sides. Okay, but in this example it is not because of that. In this example it is based on the voltage divider. Okay, so you're going to see that attenuation produce a value less than 1. That means the output is less than the input. Okay, so attenuation also use the symbol A. Okay, in Wayne Thomas's book it still use the same same parameter A. So A is used for the gain and also for the attenuation as well. Okay, so A is out over V in, and you will produce less than 1. Okay, so if A less than 1, we call it as attenuation. If A more than 1, we call it as gain. Nampak Kalau A kurang daripada 1 panggil attenuation, A lebih daripada 1 dipanggil gain. Okay, kurang 1 attenuation, more than 1 is gain. Okay, so for a cascaded total attenuation also calculated using the same way, A1 multiply A2 multiply A3 multiply A4 and so on. Okay, remember later you're gonna see that this A total can be a combination of gain and also attenuation together. So no problem, you can directly multiply all of it. Either the A is a gain or attenuation, you can multiply it together. Okay, that one you're gonna see in the next example. Okay, so for example, like in this voltage divider, so we have the input voltage over here connected to the ground, and then we have two resistors R1 and R2. So the output is measured from this point to the ground. Okay, so V out is equal to V in multiplied with R2 over R1 plus R2. Okay, because this is to the grounds. Okay, so that means this calculate from R2 divide with total resistance. So R2 divide with R1 over R2, this is what we call as the attenuation. Okay, so here is 100 ohm divide with the total resistance 300, so the value is 0.33. And then if you see that 0.33 multiplied with the V in, so you're going to produce V out less than the V in. Okay, example, another example about attenuation. Okay, so you see the picture above. Okay, about the loss stage, loss circuit, loss component. Okay, so you see that the picture they use the picture of a rectangle like this to show the attenuation process happens inside the system. Okay, previously using the triangle like this for gain. Okay, so you see that the input is 3 volt. You are given attenuation. Why attenuation? Because less than 1. 0.2, 0.9, 0.06. If you see the value of A less than 1, of course it is the attenuation. Okay, so in this example wants to find how much is the V out. Okay, how much is the V out? So in order to find V out, first you need to find the A total. A1 multiply A2 multiplied A3, so you get 0.2 multiplied 0.9 multiplied with 0.06, so you get 0.0108. Okay, So the V out is calculated by using A total multiplied with the input voltage. Okay, when you multiply this 0.0108 multiplied with 3 volt, so you will get 32.4 millivolt. Okay, you can try using your calculator and see whether you can get this value or not. Okay, boleh cuba guna calculator. Okay, and then what? Then it said the picture below is about the offset process. How can we offset the attenuation? Offset here means that we want to eliminate the attenuation. We want to make the system back to neutral. Okay, so offset, the term offset here, that means we want to produce V out equal to V in. Offset. Okay, that means A total, okay, that means A total equal to 1. We offset. Okay, we remove or we eliminate the attenuation. How to do that? Okay, so let's look from the example on the right side here. So you see that first of all, at this point, as we do in the previous slides, okay, we can find the attenuation factor A. Okay, so A parameter is equal to, at this point, okay, before this amplifier, at this point we can calculate the attenuation to be equal to 250 divided with the total resistance, 250 plus 750, so 250 divided with 1000, so we get 0.25 attenuation at this point. And if we want to calculate the V out at this point, okay, that means V out is equal to 0.25 multiplied with the V in. And in this case, the output gonna be less than the input. So now the issue is, how can I make the V out equal to V in? How can I offset the attenuation? In order to offset, I need to introduce an additional amplifier with a gain of A2. Okay, so that A total becomes A1 multiplied with A2 and equal to 1. Okay, so how much gain do I need? Okay, how much gain do I need? So A2 is equal to 1 divided with A1. Okay, 1 divided with 0.25, so we get 4. Okay, so I need additional amplifier with the gain of 4 so that I can offset the attenuations. Okay, so you see that 4 multiplied with 0.25, I will get the A total equal to 1. And in this case, I managed to offset the attenuation by making the output equal to the input. Nampak Okay, so this is about the offset process. Okay, and then what? Combination, loss and also gain. Okay, loss and gain. So you see that here we have a loss stage, we have the amplifier, we have loss stage, amplifier again. Okay, so loss stage has a value less than 1, gain A value more than 1. This is loss and this is the gain. Okay, and you see that how can we calculate the output? Okay, if you want to calculate one by one, it's also okay. Okay, for example here 1.5 volt multiplied with 0.1, so you get 0.15 volt over here, and then 10 multiplied with 0.15, you get 1.5 volt. 0.3 multiplied with 1.5, you get 0.45 volt. 15 multiplied with 0.45, so you get 6.75 volt. This is if you calculate one by one. You can also calculate directly. First of all, you need to find the A total. A1 multiplied A2 multiplied A3 multiplied A4. Regardless this is gain or attenuation. Okay, tak kira dia adalah gain atau attenuation, we can multiply all together. Okay, so when you multiply it all together, you're going to get 4.5. Okay, so 4.5 multiplied with 1.5 volt at the input, you will produce 6.75 volt at the output. Okay, you boleh try, use your calculator. 4.5 multiplied with 1.5, so you get 6.75 volt. Okay, so remember, the gain and also the attenuations can be combined together in the calculation. Okay. Okay, if you have question, please ask question. Okay, otherwise I move to the next example. Okay, so the next example is based on figure 1.7, which has the value of R1 10 kilo ohm and R2 47 kilo ohm. Okay, figure 1.7 is this one, which is a voltage divider. So this is for the offset process example. Okay, so that means you have the so you have the input, you have the V in over here. Okay, V in, and then you have a resistor R1 and also R2. Okay, and the output is from this point to the ground. So this is R1, R2. Okay, so this is 10K. This is equal to 47. Okay, and this is the V out. So what is the attenuation? What is the attenuation? Attenuation is V out over V in. That means you need to find R2 divide with R1 plus R2. This is attenuation. So this is 47 kilo ohm divide with 10 kilo ohm plus 47 kilo ohm. Okay, 10 plus 47. So this is equal to how much? 47 divide with 57. So you get 0.82456, 824, or you can 825. Okay, so if you ask me what is the best, how many decibels should you use in the exam? Okay, how many? Okay, my advice is to use at least 3 decimal point. Okay, 8 to 5. If you want to use more than 3, that's good, no problem. Okay, practice yourself to calculate up to 3 decimal point, so that you can give the more precise answer. Okay, so this is the attenuation. Okay, and then what amplifier gain would you need to offset? So that means I need to introduce an amplifier, okay, which has the gain of A2. Okay, how much? I don't know. Okay, so this is attenuation is A1. So that means I need to find A2. So A2 is equal to 1, because I want to offset, the total must be 1, divide with A1. So this is equal to 1 over 0.825. Okay, so 1 over 0.825, so you will get 1.212. 1.212 of gain. I need gain of 1.212, so that I can offset the attenuation. Nampak I need to introduce an amplifier which has a gain of 1.212 so that I can offset the attenuation. Okay. So if you have question, you can ask. Otherwise, I will move to the next example. Okay. Kalau ada soalan boleh tanya anytime, no problem. So the next example. Okay, the next example. An amplifier has a gain of 45,000, very big, which is too much for the amplification. Okay, so you have the amplifier, the gain is 45,000. So you say that the scenario is like this. So I suggest you to draw, okay, so that easy to understand. A is equal to 45,000. So what? And then with an input voltage 20 micro. So input voltage is given 20 microvolt. Okay. What attenuation factor is needed to keep the output voltage from exceeding 100 millivolt? Let A1 the amplifier with gain 45,000, A2 the attenuation factor, AT is total gain. So that means this is A1, and the question asks, I need another loss stage, okay, so that I can keep the output V out to be equal or less than 100 millivolt. How much attenuation do I need? How much attenuation do I need? Okay, so therefore, therefore first of all you can find that A total is equal to A1 multiplied with A2. So you get here 45,000 of A2. Okay, and then what? Okay, so now we want to find the A total. Okay, so that means you can use these equations. V out is equal to A total multiplied with V in. Okay, so I can take the upper bound of the output. Since I don't want to exceed 100 millivolt, I can use the upper bound for this one. Saya akan gunakan limit yang atas. So I will use the V out as 100 millivolt, which is the upper bound, the maximum value. Okay, so in this case 100 millivolt is equal to 45,000 A2 multiplied with V in multiplied with 20 microvolt. Okay, 20 microvolt. Okay, so 100 milli divide with 20 micro. Okay, so 100 milli divide with 20 micro. So use your calculator. 100 millivolt divide with 20 microvolt. So you get 5,000 is equal to 45,000 of A2. Okay, so A2 is equal to 0.111. Okay, A2 is 0.111. So therefore I need attenuation factor of 0.111 or less, so that I can keep the voltage to be equal or less than 100 millivolt. Okay, if the attenuation factor is more than this, there might be a possibility that the output is more than 100 millivolt. Okay, so that means, okay, you must make sure that A2 is equal or less than 0.111. Okay, so that you can keep the output voltage. Okay, you can keep the output voltage to be lower than the 100 millivolt. Okay. If you have question, please ask. Otherwise, I will move to the next slide. Okay, saya akan teruskan. Okay, if you have question, please ask. No problem. I can explain again. Otherwise, we move to the next slide. Decibel gain. Okay, decibel gain. A student previously, one student asked about the gain. Siapa tadi yang tanya pasal gain? So the gain also can be expressed in terms of decibel. Previously, we saw the gain in terms of unitless parameter. Now we can convert the gain into a decibel parameter, dB parameter. Okay, how to convert that? That means 10 log of absolute value. 10 log of a value will produce decibel. Okay, for example, if the value of 2 convert into dB, so 10 log log base 10, 10 log 2 you get 3 dB. This is actually 2 point something. So it has been rounded up to 3 dB. 10 log, if you try using your calculator, 10 log, 10 log 2, you will get 3.0102999. Okay, so in your notes, sometimes the value is rounded up so that easy for you to understand. Okay, sometimes nilai itu dibundarkan supaya mudah untuk pemahaman pelajar. Okay, and then what? You can convert 0.5 into decibel. So 10 log 0.5, you will get minus 3 dB. Okay, so when we get minus, it is referring to loss. Okay, so of course in the absolute value, this is referring to the attenuation, and in terms of decibel, it has the negative sign which show the losses. Okay, so why do we need to use a decibel? So the good thing about decibel is that we can represent large number of value into a smaller values of decibel, or we can represent a very small value in absolute value into a bigger value in decibel. Okay, nilai yang sangat besar dalam absolute value boleh diterjemahkan dalam satu nilai yang lebih kecil dalam decibel, ataupun nilai yang sangat kecil dalam absolute value boleh diterjemahkan sebagai nilai yang lebih besar dalam decibel, so that easy for us to do the calculation. Later you're going to see decibel will helps you to do the calculation. Okay, using a decibel, total gain or attenuation can be calculated by simply adding the gains and attenuation expressed in decibel. Okay, so what does this sentence means? Okay, remember previously you multiply the gains or the attenuation. Remember this one, A1 multiplied with A2 multiplied with A3. Okay, but what if we use the decibel? Macam mana kalau kita guna decibel? See, so you see that if we want to express in terms of decibel, for example here, dB. Okay, A total in dB is equal to A1 in dB plus A2 in dB plus A3 in decibel. Okay, so decibel, so that means multiplication process in absolute value is corresponded to the summation process in the decibel. And then division process, okay, kalau ada division, division process in absolute value is represented with minus in decibel process. Okay, proses bahagi diterjemahkan dalam bentuk proses tolak dalam decibel. Proses darab dalam absolute value diterjemahkan dalam diterjemahkan sebagai proses tambah dalam dB. Okay, so we're gonna see example about this later. Okay, decibel power. Okay, so you see that decibel power, the unit is dBW, dBm. dBW is a dB watt, dBm dB milliwatt, dB microwatt, and etc. You see what's the difference? All of this in dB. So you see that this one, this slide, this is the decibel representation for a value without a unit. A value without a unit, for example, 10, 5, 1. So this is a value without a unit. When you convert all of these values, you will produce dB, decibel. But different with power, we have 10 watt. We have, for example, 5 milliwatt. We have, for example, 2 microwatt. So these are the values with unit in terms of power. And when you convert into decibel, it has either the way we write the symbol is dBW, dB watt, dB milli, dB micro, and so on. Okay. So how do we convert into dB? Of course, the process is still the same. Okay. So let's go, look into the last. I want to show the last first. Okay, because this is easy to understand. Okay. So for example, you have 1000 milliwatt. 1000 milliwatt is equal to 1 watt. Of course, when you want to convert into dB, so that means 10 log the power 1 watt, this one. And since you want to produce dBW, that means the reference, the denominator is the reference value. The reference is 1 watt. Okay, so 10 log 1, you get 0 dBW. Okay, let's look at another example. Example number 2 over here. You want to produce dBm, dB milli. So what happened? So you have a 1000 milliwatt. 1000 milliwatt, you want to convert into dBm. Okay, so 10 log power, 10 log 1000 milliwatt, divide with a reference value. Since you want to produce dB milli, the word here is milli. That means you need to divide with the reference value 1 milli. So 1000 milliwatt divide with 1 milli, and then you do the 10 log of the in bracket. So that means you want to produce everything in the bracket in terms of milli. Okay, so 30 dBm. Ni cuba. So before that, sorry. Okay. So before that, you know how to find the log, right? So please use your calculator now, okay? So try use your calculator. 10 log 1000. Okay, because milli and milli has been cancelled out. Okay, milli and milli can cancel out. So 10 log 1000, you get 30. 30 of what? 30 of dBm, because you divide with 1 milli. Okay. And then what? For example here, 1 milliwatt, convert into dBm, dB milli. So 1 milliwatt, you want to convert into dBm, that means 10 log 1 milli, the power, divide with the reference 1 milli. Okay, so you do the log is 10 log of 1, you get 0. 0 of what? 0 of dBm. Okay, So you see the difference. Okay, so for example, if I want to convert one, for example, like this one, okay, this one, so for example, this one I want to convert into dB micro, for example. How to convert into dB micro? So I have 1 watt here, this one, 1000 milliwatt, which is 1 watt. I want to convert into dB micro. That means 10 log the power 1 watt. I want to produce a dB micro. Okay, that means my reference would be 1 times 10 power of minus 6, 1 microwatt. Okay, 1 microwatt. Okay, so I need to divide this one. So 1 divide with 1 micro. Okay, and then 10 log of answer, 10 log 1 million, I get 60. 60 of what? 60 of dB micro. Okay, if you want to find again, if you want to normally we ask up to dBm and dBw. Okay, normally we ask up to dBm and dB micro. So the reference value determine the unit for the output, either dBw, dBm, or dB micro. Okay, so for this let's do example so that you can have more understanding about this. Okay, so let's do the example, this example. So remember this, you are given power in milliwatt, you are given the answer in dB milli, and you need to find the answer in dBw. Okay, so you are given 0.01 milliwatt, convert into dBm. So for example, the first one here, okay, the first one here, so 10 log, okay, 0.01 milliwatt, because this is in term of milli. So we want to produce dBm, the first one here. Okay, so I need to divide with 1 milliwatt. Okay, so that I will produce dBm. Okay, so use your calculator. 10 log 0.01, you get minus 20. Minus 20 of what? Minus 20 dBm. Okay, if I want to convert into dBw, that means 10 log 0.01 milliwatt divide with 1 watt. So I will produce dBw. Okay, so this is 10 log 0.01 milli. So I get minus 50. Minus 50 of what? Minus 50 dBw. Okay, boleh follow, and then let's look the second one. Okay, second one is a 0.1 milli. So if I want to convert into dBm, so that means 10 log 0.1 milliwatt divide with 1 milliwatt, reference value. Okay, so I will get the value of 10 log 0.1. So I get, 10 log 0.1, I get 10 log 0.1, I get minus 10. Okay, dBm, which is this one. Okay, and if I want to convert into dBw, that means 10 log 0.1 milliwatt divide with reference 1 watt. Okay, I will get the value in term of dBw. Okay, so that means 10 log 0.1 milli, which is minus 40 dBW. So this is minus 40 dBW. And then what? The last one, 1000 milliwatt. Okay, 1000 milliwatt, that means this is for this one. So 10 log 1000 milliwatt. I want to produce in term of dBm. So I divide with 1 milliwatt reference value. So this is gonna be in term of dBm. How much I gonna produce? This is 30 dBm. Okay. If I want to produce dBW, that means 10 log 1000 milliwatt divide with 1 watt. Okay. So this is equal to 0. Okay, equal to 0 because this is 10 log 1. 10 log 1, you get 0. So this is actually equal to 0. The rest you can do on your own, no problem. Simple. Okay. Anybody want to ask question? You can ask now, no problem. So please practice using the calculator. Okay, practice now. Use your calculator. Try to find the log answer and so on, because this is gonna be come out in the final exam and also in the test. Okay, about the conversion process. Okay. Okay, decibel power ratio. Okay, if you don't have question, I will move to the next slide, which is decibel power ratio. Okay, power ratio, ratio of power. Okay, ratio of power. When you divide power and power, okay, when you divide power, okay, x watt divide with y watt, okay, you will produce a value without a unit. And when you convert this, it will become dB, not dBW. Okay, so this is ratio, power ratio. Okay, so when you want to convert power ratio, okay, power ratio is normally used in the gain, attenuation, and also the SNR. Okay, but in terms of decibel, that's slightly different. You see that about the power ratio. So this normally students tends to do careless mistakes about this issue. Okay, remember for power ratio, the way we calculate is 10 log P1 over P2. So this 10 is supposed to be subscript. 10 log P1 over P2, and the unit in term of decibel. Okay, so let's look at the example below, like this one. Let's start with the power. Okay, for power ratio in dB, 10 log P out over P in. Okay, so you're gonna get a value in term of decibel. Okay, what about in term of voltage or current? Macam mana pula kalau dalam bentuk voltage atau current? So it becomes 20 log V out over V in, or 20 log I out over I in. So where does this 20 comes from? This is not a magic number. Okay, this is not a magic number. Again, this is based on the Ohm's law. Remember, V equal to IR. Okay, remember power is equal to I square R. Or power also can be equal to V square over R. This is RMS. Or if it is a peak value, it is a VP square divide with 2R. Okay, so what happened is that it is actually like this. 10 log. Okay, P out, for example, we want to use a VRMS square, for example. So VRMS square divide with R. Okay, this is for the out. Divide with VRMS square for in over R. Assuming the R is the same. Okay, assuming the R is the same, so that means you're going to produce V out RMS over V in RMS square, and over here you have 10 log. So this value of 2 can be put in front, so that's why it becomes 20 log V out over V in. Okay, 20 log. Similar with the current. Okay, similar with the current. So that means for the current, okay, for the current, so for the current is it's actually like this: 10 log I in square R divide with I out output, I out square R divide with I in square R. Okay, so R can be cancel out, so that means it becomes 10 log I out over I in divide with, this is square, so this square can be put in front, so that's why you get the 20. Okay, so remember, this is not 20 is not a magic number, it is based on the mathematics calculation. Okay, so when you get a power ratio, you want to convert into decibel, you can use the 10 log. When you get the voltage or current ratio, you want to convert into dB, you need to use 20 log. So be careful about this. So students tends to do careless mistakes about these issues. Okay, this is for the ratios: power ratio, voltage ratio, or current ratio. Okay, so if it is a ratio of voltage, you want to convert into dB, it is actually 20 log V out over V in. Okay, when it is current, you want to convert into a current ratio, I out over I in, you can use the 20 log I out over I in. So this is what you have seen in the gain previously. Okay, and when you want to convert into decibel for a voltage gain, okay, you need to use 20 log. And when you use a power gain, remember previously it also can be described as a power gain. Power gain, when you want to convert into decibel, you can use 10 log of P out over P in. Okay, just be careful about this. Okay, about the ratios. Okay. Okay, if you have question, please ask. Otherwise, I will move to the next example. Okay, kalau ada soalan boleh tanya. Otherwise, I will explain the next slide. Okay. Okay, example 1.6. A microphone has an output value minus 50 dBm. Calculate the total the actual output power. Okay, so you have a microphone system like this. It has the output power equal to minus 50 dBm. What is the actual power? How much this one in terms of watt, milliwatt, or microwatt? How much? Okay, so what you can do is like this. So 10 log, okay, 10 log of, remember previously we do power divide with a reference value, 1 milli, right? Okay, 1 milliwatt. So this is equal to minus 50 dBm. Okay, minus 50 dBm. Okay, so what I can do is that I can represent this in bracket as x. Okay, so that means 10 log of x is equal to minus 50 dBm. Okay, I know that x, okay, x must be in term of milliwatt. Why? Because this is milli. Okay, the answer that I will produce is in term of milliwatt, because I divide with 1 milli. Okay, so that means x log x is equal to minus 5 dBm. Okay, and I do here, so x is equal to anti-log 10 power of minus 5. Okay, anti-log. Okay, so I will get 1 times 10 power of minus 5 . Okay, so anti-log 10 power anti-log of minus 5, you can use your calculator. Use your calculator shift log. Okay, in my calculator I use shift log. Okay, so shift log minus 5. Okay, so I get 1 times 10 power of minus 5. So what's the unit? The unit is in term of milliwatt. If I want to convert into watt, that means this is 1 times, so this is minus 5 and minus 3 for the milli. So that means 1 times 10 power of minus 8 watt. Okay, so if let's say, okay class, if let's say the unit over here is dBW, okay, that means x, the value of x that I will produce is in term of watt. Okay, if this unit is actually dB micro, that means the value inside the bracket that I produce is in term of microwatt. Nampak beza dia? So you see the difference? So everything inside the bracket, since we use a dBm, that means everything inside the bracket in term of milliwatt. If given as dBW, that means everything inside the bracket will be in watt. If this is a dB micro, that means everything inside the bracket will be microwatt. Okay, so you need to practice about this conversions process, so that easy for you to answer the questions later. Okay, ni ada soalan. Do you have question to ask? You can ask now, anytime. I can explain to you. So if you don't have question, let's move to the final example. Ada soalan nak tanya? Kalau tak ada, kita akan pergi kepada slide berikutnya, the next slide. Okay. So if you don't have question, you don't ask question, that means I assume that you understand this example. This is a straightforward example. And you need to practice the conversions of dBW, dBm, and so on. Okay. The last example. This is a very good example. Okay, this is a good example to practice for the final exam. Okay, because this is about the 3-stage cascaded system. Okay. So you see that here for a 3-stage system with the input power of minus 20 dBm and power gains 13 dB, 16 dB, minus 6 dB. This is a power gain. Okay, so that means you can draw you can draw the picture. You can draw. This is a cascaded. Okay, and you see that I saw that this is a minus, so this is a loss stage, like this, for example, like this. Okay, so this one is A1 is equal to 13, A2 is equal to 16 dB, A3 is equal to minus 6. Given the input is minus 20 dBm, P in. So the question asks how much the output power in dBm and in milliwatt. How much is the P output? So this is the question. Okay. So for your information, we normally ask questions something like this in the final exam, but what we did is slightly different. For example, contoh for example, we like to do like this. We give the gain with there's a gain with a decibel and another gain without a decibel, which is in terms of absolute value. For example, we give you like this: A1 13 dB, A2 16, A3 equal to minus 6 dB. So be careful about this. Okay, so when you get this kind of question, that means you need to make sure, if you want to calculate in terms of decibel, make sure everything in terms of decibel. Okay, so be careful about that. If you want to do calculation in absolute value, you need to do anti-log for all of this. Okay, okay, so be careful about that. Okay, so I will show you the fastest way. Okay, the fastest way to calculate the answer. Okay, the first question in dBm. Since the input is in term of dBm, okay, the input is in term of dBm, so it is easy for me to calculate the P out in dBm. More easier if I do in term of decibel calculation. Okay, lebih mudah untuk saya menggunakan decibel calculations to find the dBm. Okay, so I will show you like this. Okay, so it is like this. So remember previously, P out is equal to A total. Okay, A total multiplied with P in. You remember this? So this is the calculation in terms of absolute value. However, if you want to make it in terms of decibel, it will become like this. Okay, so P out in dBm is equal to A total in dB plus, remember, multiplication in absolute value calculation is represented as summation in the decibel calculation. Okay, so A total plus P input in term of so since this is dBm, that means this must be in term of dBm. Okay, if this is dBW, so let's do like this. If this is dBW, that means this is also dBW. Okay, if this is a dB micro, that means this is also dB micro. Okay. Why is it like this? Kenapa macam ni? So the question is why. Okay. So you see that like this. I give you example. 5 watt multiplied with 10. How much is this? This becomes 50. 50 of what? 50 of what? Okay. Similarly like this. 5 milliwatt multiplied with 10, for example. This becomes 50. 50 of what? 50 of milliwatt. Okay. Another example. 5 microwatt multiplied with 10. So you get 50. 50 of what? 50 microwatt. Okay. So similar with this example, that means this is in terms of dBm. Okay. And this is dBm. Okay. So therefore I need to find A total in terms of dB. Okay. So A total in terms of dB, A total in terms of dB is equal to A1 in terms of dB plus A2 dB plus A3 in dB. Okay. So this is equal to 13 plus 16 dB plus minus, so this is becomes minus 6. Okay, it becomes minus 6. So this is 23. Okay, so once I get this, that means I can calculate the P out. Okay, so P out in dBm is equal to 23 dB. Okay, based on this one, based on the above equation, plus 23. Plus this is so plus minus 20 dBm. So that means this becomes minus 20. Okay, so it becomes 23 minus 20 becomes 3. The unit dBm. Okay, and if I want to convert into micro, that means 10 log. So this is number 2. 10 log 3. So 10 log x. So 10 log x is equal to 3 dBm. Okay, x is equal to antilog of 0.3. Antilog of 0.3. Okay, so antilog of 0.3 shift log 0.3, so you get 1.9956. Okay, so you get here is 1.99526 in terms of what? In terms of milliwatt. Okay. Another way, you can also do another way if you like. Okay, there's another way. There's many ways, no problem. So if you have a better answer than mine, please use your answer. Okay, If you can do better than me, use your solutions. If you have better solution, use your solution. Okay. Another way is that you can convert each of these A. Okay, you can convert each of these gain. So A1 anti-log of 13 dB. Okay, anti-log of 13 dB, how much you will get? So shift log 1.3. We need to divide with 10 first, then do the anti-log. Okay, bahagi 10 dulu baru buat anti-log. So this is actually equal to 19.9526. 19.9526. Okay, 9526. Anti-log of 1.6. Shift log 1.6. So 39.8107. This is 39.8107. And A3 is equal to anti-log minus 0.6. I need to divide with 10 first. Okay, so this is actually 0.2512. Okay, and when you want to find the A total, okay, you multiply it all together. Okay, A total, sorry, so A total equal to A1 multiplied with A2 multiplied with A3. Okay, so you try to multiply all of this. So let's try. Okay, cuba. Okay, so 19.959526 multiplied with 39.8107 multiplied with 0.2512. So I get 199.5349. 5349. This is the total gain. Okay, and I need to convert the minus 20 dBm. Minus 20 dBm, if you convert into power, you will get the value of how much? Convert this one. So 10 log x equal to minus 20 dBm. So x is equal to how much in milliwatt? Okay, so you divide with 10. Okay, divide with 10 and then you do the anti-log. So anti-log of minus 2, you get 0.01. 0.01 milliwatt. Okay, from here you can find the P output in milliwatt. So P out in milliwatt is equal to A total multiplied with P in milliwatt. So that means this one so 199.5349 multiplied with 0.01 milliwatt. Okay, so how much you get? Multiplied with 199.01 milli multiplied with 199.5349. So you get 1.9953 99535. So same, it's the same in terms of milliwatt, same answer. Okay, 995. Jawapannya adalah sama. So it's up to you which one you like. Okay, there are many ways to find the answer, so it's up to you which one you like to use. Okay, any question?
Doktor.
Yeah.
Jawapan tu nak dalam berapa decimal places?
Which one? The final answer? Okay. If the question like this, the question does not specify exactly how many decimal places, so it's up to you. Okay, it's up to
Okay.
you. If you ask
Okay.
me what is the best way, as I told you previously, that I recommend you to write up to 3 decimal point. I recommend up to 3 decimal point. That's the best in
Okay.
my opinion. Okay. If the question does not specific about this, so it's up to you. Okay. But I recommend up to 3 at least. That's the best way, so that you can give the more precise answer. Okay. Melainkan if the question specifically mentioned that up to 4 decimal point, then you need to use up to 4. Okay. Kalau soalan tak cakap, so it's up to you, no problem. But the good thing to have a more decimal point so that you can produce more accurate answers. Okay. Ada lagi? Any more question?
Tak ada.
Okay. Ada Yang lain? If you understand this, I believe you can answer the question in the final exam. Okay. Okay. So this is a good example for the final exam. Okay. You can try to practice this example. Okay. If there's no question, I want to show you another slide. Wait. This one. Okay. These notes has been put in the author. This is about the absolute ratio dB, dBm, dBw. So these slides are by Dr. Khairul Nizam. Okay, this is a good slides about the conversions of dB, dBm, and so on. Okay, I suggest you to learn from these slides, from these notes also, so that you can have more understanding about the conversion process. Okay, so absolute ratio is a value without a unit. Okay, when you convert absolute ratio, it will become dB. dBm, dBw, this is for the watt, for the power. Okay, conversion. So convert the following gain values into absolute value. Convert the power gain. Remember, this is the power ratio. Okay, to absolute value. Okay, so 10 dB, 10 dB, 0 dB, and minus 10 dB. So you need to do the anti-log. So first of all, you need to divide with 10. Okay, divide with 10, and then you do the anti-log, shift log. So you get 10. Okay, 0 dB, divide with 10, and then do anti-log. Anti-log of 0, you get 1. Minus 10, anti-log of minus 1, because you divide with 10. And then you get 0.1. 0.1 is attenuation, because less than 1. Okay. Convert the following values to dBm. dBm means that you need to divide with a reference value 1 milli. Okay. So 10 log power divide with the reference 1 milli. So it becomes minus 30 dBm. You can use your calculator to check this one. Okay. So 10 log, the second one is 1 milliwatt, and the last one is 1 watt. Okay. So 1 milliwatt divide with the reference 1 milli. So you get 10 log 1, you get 0 dBm. Okay. So 0, and then the last one is 1 watt. You want to convert into dBm, so divide with the reference 1 milli. So you get 30 dBm. Okay. Convert the following into milliwatt. So now you are given into milli. You are given a milliwatt. You are given a dBm, dB milli. You want to convert into micro. You want to convert into milliwatt. Milliwatt. So this one is easy. Okay. So that means everything inside the bracket will be in term of milli. Remember previously we do a P power divided with a reference value, power without the reference value, 1 watt. Okay, so this is like I did previously, that this is X. Remember 10 log X equal to minus 30 dBm. Okay, so that means 10 log power in milliwatt equal to minus 3. I divide with 10, and then P in milliwatt, we get 10 power of minus 3 milliwatt. Okay, 10 log P in milliwatt equal to 0 dBm. How much is this? Power in milliwatt, 10 log power in milliwatt is 0. Power in milliwatt is 1 milliwatt. Okay, 10 log power in milliwatt equal to 30 dBm. This is like here, this one, 30 dBm. So anti-log of 3, you get 1000. Sorry, 1 times 10 power of 10 power of 3. So 1 times 10 power of 3, so 1000 milliwatt. Okay, and then what? Convert the following in to dBW. So this is direct conversion. 10 log 10, 10 log 1, 10 log 1K. Okay, so you get 10 log 10 is 10 dBW, 10 log 1 0 dBW, 10 log 1000 30 dBW. So here is actually the reference value is 1. The reference value is 1. So 1 we don't need to show in the calculation, so we understand that this is 1. Okay, convert the following dBW to watt. This is directly conversion of the anti-log of 10, anti-log of 0, anti-log of 30. Okay, since this is W, so I can directly produce watt. Okay, so 10 log power in watt, this is 10 dBW. So 10 log power in watt equal to 1, power in watt equal to anti-log of 1, you get 10 watt. Okay, 10 watt. Power in watt, how much is this? For we want to convert 0 dBW, so anti-log of 0 we get 1 watt. Okay, and then what? 10 log power in watt that produce 30 dBW. So anti-log of 3, okay, anti-log of 3, you get 1000. 1000 of what? 1000 of watt. Okay, combine power in log scale. Okay, so you see that example 1 milliwatt plus 1 milliwatt, so we get 2 milliwatt. This is a mathematics. Okay, mathematics for summation. Okay, and about this one, this is forbidden to do the calculation directly. You cannot plus dBm and dBm straight away. You cannot plus dBW or dBW straight away. Okay, dBW plus dBW also is not allowed. dB micro also plus dB micro is not allowed. Okay, tidak dibenarkan straight away calculation like this. You need to convert into power, then you do the summation, then you convert back into dBm. Okay, so what you need to do first, you need to convert into power, 0 dBm, convert into power, you get 1 milliwatt. Okay, so you get 1 milliwatt and 1 milliwatt. So 0 dBm plus 0 dBm is equal to 1 milliwatt plus 1 milliwatt. You get 2 milliwatt, so this need to be converted into dBm. So 10 log 2 milliwatt, okay, 10 log 2 milliwatt divide with reference 1 milliwatt. Okay, so 10 log 2, you get 3.01 dBm. You see what happened? You cannot plus dBm and dBm. You cannot plus dBw and dBw. Okay. If dB plus dBm, allowed. dB plus dBw also allowed direct calculation, like what we do, like what we did in the previous slides. Also dB micro. Okay, this is allowed direct summation. Boleh ditambah terus. Different from this one. Okay. This one. This also not allowed to do the this is allowed because this is dB plus dBm. dB is a representative of a value with a unit. dBm is a representative of power in milli. So you can do direct summation. This is allowed. Okay. And then what? This is not allowed. Okay, you cannot directly do the summation. You need to convert into power. Convert 0 dBm, convert 5 dBm. Okay, so convert 0 dBm into milliwatt, you get 1 milliwatt. Convert 5 dBm into power, so you get antilog of 0.5, you get 3.1625 milliwatt. From here, you can do the summation power and power. Okay, do the summation power and power. You get this one total. Then you need to convert into milliwatt. Okay, so 10 log 4.1623 milliwatt divide with reference 1 milliwatt. Okay, so this milli and milli can be cancelled. So 10 log 4.1623, you get 6.193 dBm. Okay. Zero dBm and 0 dBw. So this is also not allowed because both of these are the representative of power. You cannot just straight away plus. You need to convert into power first, then you need to convert back into dB. Okay, so 0 dBm convert into power, you get 1 milli. 0 dBw convert into power, antilog of 0 you get, okay, antilog of 0 you get antilog of 0 you get 1 watt. Okay, 1 watt. Okay, so 1 watt plus 1 milliwatt, you get the 0 dBm plus 0 dBw. So you get 1001 milliwatt because 1 watt is equal to 1000 milli. So 1001 milliwatt. 1001 milliwatt convert into dBm. So 1001 milliwatt divided with reference 1 milliwatt. So this is 10 log 1001. So you get 30.0043 dBm. Okay. And if you want to convert into If you want to convert into dBw, that means you need to divide with reference value 1 watt. So 1001 milliwatt divide with 1 watt of reference value. Then you do the log 10 log of this. So you get 10 log of 1001 milli. So you get 0.0043 dBw. If you understand the conversion, you see that the difference between dB and dBm is always 30. Okay, perbezaan antara dB and dBw and dBm is always 30. Okay, that's all. Okay, so maybe I can wait. Do you have questions about this? If you don't have questions, maybe I can flashback about this. I just want to show you a little bit about this. Okay, and you see that the difference between dBm and dBw, okay, is 30. Okay, this one, the difference is 30. Also this one, the difference is 30. So if you are familiar with this conversion, you directly know that the difference is 30. Okay, that's all for today. That's all for today. Students, are you still there? Can anyone respond?
Yes.
Okay, thank you for the response.
Yes.
Okay, so today we can finish earlier. Okay, today we can finish earlier. So we can take the attendance and then you can leave to other places. Okay. So luckily we can finish earlier, so I can prepare for other things after this. Okay. So you can open your QR code scanner. Okay, open your QR code scanner. You can scan your attendance. Okay, so you can scan your attendance and see you again next week.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay,
Thank you,
welcome.
Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome. Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Dokter.
Welcome.
Thank you, Dokter.
Terima kasih, Dokter.
Okay, welcome. Sama-sama.
Thank you, Doctor.
Okay, welcome.
Thank you, Dokter.
Okay, welcome.
Doktor, saya tak boleh scan
Okay,
lah.
Doctor. Assalamualaikum.
Salam. Okay, nama siapa?
Thank you, Doctor.
Okay, welcome.
Muhammad Hamsyari.
Muhammad?
Hamsyari Hamizan.
Muhammad Amsyari Amizan. Okay.
Okay,
Okay,
thank you,
dah.
Doktor.
Okay, welcome.
Doktor.
Yeah?
Aku Kendra, Doktor.
Okay. Okay, that's all for today. See you again
My
next
name
week.
is Sundus.
Yeah?
My name is
Thank you, Doctor.
Sundus.
Sundus already, this one you already scan your attendance? Already done?
Okay, thanks a lot.
Okay, welcome.